Here's how things look on the water vapor imagery this Friday afternoon. We can make out the long wave pattern on the east coast. This whole area right here is part of a long wave trough, and then further out west, as we would expect, seems like it happens all the time, long wave ridge on the west coast. And if you don't believe it, check that out. This is the 500 millibar height anomaly, a center right there over Nevada, California. Height anomaly over the past 3 months. Height anomaly over the past 6 months. And as a result, this is what we have on the National Drought Monitor. Drought conditions from Northern California all the way into Arizona, across Utah into the Grand Junction, Colorado area, and even down to Albuquerque, Midland, Odessa, and the Big Bend. And the 3-month outlook, more drought and above average temperatures. They just don't get a break. The National Weather Service in Phoenix reporting another 100-degree day just 4 minutes ago. They've recorded 145 days this year of 100-degree weather. We're on day 290 of the calendar year. So that means exactly half of the days this year have been 100 degrees or over in Phoenix. By many different metrics, this has been the hottest summer on record in Phoenix. This really makes you wonder if this is becoming the new climatological normal. Returning to our analysis of weather across the U.S., looking at the system in New York, you can see on the backside there's kind of a vague S shape, and our rule of thumb indicates that just behind that you're going to find a shortwave oriented roughly like that. And sometimes when these backsides are very smoothed over with very little curvature, your shortwaves will be oriented more parallel to the flow. And there it is on the 500 millibar heights and vorticity. Looks like it's broken up into 2 shortwaves. There's one right there. I'm going by the axis of highest vorticity value. And then there's another axis kind of roughly right there, extending from vorticity center pretty much over the Buffalo region. Further north, the flow is more channeled, and that's more indicative of the presence of a jet stream running right along that blue line, and that vorticity signature is there mostly due to the shear through that region right there. The surface map in the southeastern U.S. shows a large area of high pressure across Texas and Arkansas. The center of that high is around Paris, Texas. That's representing a large continental polar air covering much of the central and eastern U.S., and our outgoing frontal system is right there on the North Carolina coast, with the tail end front extending through northern Florida out into the Gulf of Mexico. In northwestern Mexico, you can see that front has pushed very far to the south. Monterey showing a north wind there, a cool 70-degree reading. Let's take a look at the satellite photo. And that shows the outgoing system, that S shape that's very typical of a cyclonic circulation embedded in that flow. Of course, this is actually kind of an artifact because of 2 separate layers. You've got this anvil material right here, but beneath that, yeah, you do have some dynamic lift right under there, and that corresponds pretty well to that surface low in North Carolina. The atmosphere over the southeastern U.S. worked over by dry air, and we can take a look at that on the GFS. We'll just set a dot over, let's try Montgomery, Alabama. It's going to be right about there. And that skew-t does show, yeah, there is a little bit of moisture in the mid-levels. That's based at about 8,000. So I would expect to see some altocumulus in those layers. but plenty of dry air in the low levels with that north flow, the air mass origin coming from Canada. And if we go a little further to the northwest towards Little Rock, the column is pretty much dry all the way up, and it looks like maybe there's a top to that cold air mass at about 14,000 feet. And I call that a top because if you look at the top part of the troposphere, that looks a bit warmer. And what I sometimes do is I bring that down, not quite dry adiabatically, but a little bit less than that. That's kind of a crude extrapolation, but that brings me down to a surface temperature in the 70s, maybe near 80 degrees. So I think that's part of the tropical air mass in the top part of the troposphere. The northeastern U.S. showing a lot of dynamic lift across New York, Massachusetts, New England, and then further to the west. There it is, the return of cold air advection. And the Great Lakes just filled with widespread towering cumulus lines, some cumulonimbus, and very widespread cumulus with moderate growth. And you can look at all that cumulus and read that as extensive modification of a cold air mass due to solar heated terrain. The surface map this afternoon showing the origin of that air mostly from the northern U.S. A couple of cold air advection troughs across the Great Lakes, and it looks like that front there on the east coast is still an antifront, most of the precip following back behind that. And the rain is coming down there. There's the Albany radar. Pretty much all of the Hudson Valley on the backside of this large area of rain, and much of it extending all the way down the coast through New York City, down to just east of Philadelphia and down to Delaware. So this is probably interfering a little bit with air traffic movements around New York. There's how things look in the Pacific Northwest. Looks like a embryonic Alberta Clipper coming together just south of Calgary. You can see the temperatures around Calgary in the mid-30s there, and you go to the south around Cardston, 54, with that downslope flow from the Rockies. Further south, the air mass does look mild. It looks like a recovering Pacific air mass, and temperatures already coming up to 73 out there around Pendleton. A lot of the air mass down around Nevada, that's high pressure, and there's been a lot of nocturnal cooling. It's very efficient over the deserts this time of year, so that tends to bring the pressure up in those areas. Now, one question is the mid-level flow. This is the 700 millibar chart, the jet located from Vancouver to central Montana. Based on that, we would expect to find the frontal system down to the south. So do I want to correct this? The 700 millibar jet is, of course, right around here. We should not find the surface systems north of that. So that makes things pretty tricky. If we look at the pressure and thickness, this kind of backs up our surface analysis. So I'm going to keep it like that for now. One interesting note is if you use the box method, you can see there's a lot of warm air advection right there. So in a sense, you could bring that warm front all the way down through Denver and maybe all the way to the Texas Panhandle. But I'm not really doing that because the temperatures do look kind of homogeneous at this time. The satellite chart showing a very fast-moving system tracking towards the southeast. And I think this is one of these cases where the upper-level patterns are kind of outrunning the surface features. So even though I've got the front up in this region, it looks like the mid-level fronts are just kind of pushing out ahead of the surface patterns. And what that means is that in the mid-levels, you're bringing cold air out over the tropical sector, That's going to give you a cold over warm situation, which is unstable. So you're going to have a lot of mixing that tends to bring the cold air down to the surface and push the front further south and downwards towards the surface. So that may be what's happening here. A lot of this convection in Montana, that's that process underway in combination with solar heating. And pretty clear in the southwestern U.S., but Colorado, yeah, there's that fire right there, strong downslope flow. These here, I think those might be mountain waves. They don't have the same brown color as the stuff near Boulder. Yeah, so I'm going to go with probably mountain waves, maybe some lenticular altocumulus southwest of Denver there, out towards South Park and Buena Vista. And there's the southwestern U.S. surface map. Not much to see there, but the north to south pressure gradient is increasing. And if these highs build a little bit more strongly, that can be a factor that gets the Santa Ana winds going. We're not quite up to that kind of pressure difference yet. Typically what you do is you look at the pressure differential between central Nevada and coastal California. And when that exceeds a certain threshold, you have conditions favorable for Santa Ana winds. Doesn't look like it today, though. But we do have that heat low in the desert southwest, right over Ajo, Arizona. And temperatures look like they're coming on up into the 100 range. And that's all I have for this edition of Forecast Lab. Keep in mind we will be on break next week. So in the meantime, I invite you to check out the weather on your own and put some of the skills you've learned over the past 6 months into use. And we'll be back in a little over a week. Take care. Bye-bye.